Hey, Editing Forest here. Really quick before the video starts, my air conditioner has been on the fritz all year long and I thought I had it fixed and it broke again right before I started filming this video. And I just figured I'd power through it. It was nighttime, so it couldn't have been too hot. I live in Oklahoma and that was a false assumption. So as this video progresses, you're just gonna see me getting sweatier and shinier and grosser and more agitated. So sorry, I thought about refilming this, but I figured it would be weird to go back and try to react to everything. So this is what the video is. I hope you enjoy it. Sorry I look so gross. Bye! Hey there everybody, I'm Forrest, and welcome back to Reacteria. While preparing for this episode, I thought it would be fun to get away from just talking about evolution for a minute and maybe expand into some other sciences. Maybe we could find a funny anti-vax video or a ridiculous flat earth video to react to. And while I was digging around YouTube looking for these anti-science videos, I came across a familiar name. Genesis Apologetics. And wouldn't you know it, our old friends, John and Jane. They tried to debunk evolution with their creepy trunk full of skulls, and now they're back trying to debunk radiometric dating. I am beyond excited to get started on this video, because radiometric dating is a really interesting and important part of science that's only a bone of contention with people who don't understand how it works. And last time we heard from John and Jane, if I remember correctly, they got a 4 out of 10 on the Science Teacher Challenge level scale, which is like the highest that we've had, because they raised really good questions for like a high school, maybe early college student, which I'm pretty sure is their target audience. So maybe they'll raise good questions here. Maybe we'll actually have a good discussion. Maybe we'll all learn something. Who knows? I'm stoked to get into it. But before I do, I want to thank my patrons on Patreon. I don't even know if I can fit all of these names onto the screen at the same time. I think I might need to do them in batches, like maybe one big chunk of names, and then after a few seconds, another big chunk of names, because so many of you have signed up to voluntarily donate your own hard-earned money just to help me teach the world to love science as much as I do. And I cannot express how grateful I am for that. Like seriously, I don't have words for that level of generosity. None of this would be possible without the people who watch these videos, the people who donate to my Patreon, the people who buy merch from my merch store, the people who send me tips through Cash App and Venmo and PayPal. Like, all of you are so incredibly helpful, I can't even tell you. So sincerely, from the bottom of my heart, thank you so much for being a part of my dream to teach the world to love science and themselves. I love you very much. You're all very special to me, and while I haven't actually seen most of your faces, I'm sure that you all have very kind eyes. Seriously though, if we get many more patrons, we're gonna have to figure something out, like maybe like a credits roll at the end of the video or something like that. I'll have to see what other YouTubers do, because I want to try to get you all in here as often as possible, because I'm so happy about all of you being here. And enough about that. Let's get started with John and Jane debunking radiometric dating.
Is it just me? Or is dating rocks not all it's cracked up to be?
Are all their videos gonna start like this?
Sorry, I am late, Jane.
No problem. Oh, you've been jogging?
Yeah, I'm trying to get down to weight for the wrestling match this weekend. Otherwise, I'll get kicked up to the next weight division and have to face Jimmy the Python Peretti.
Jimmy the Python?
Yeah, he got his nickname after the kid so hard that he was crawling to class for 3 days.
Don't drink the water! You'll add water weight!
That's a bad message. Drink water, especially if you've been exercising. Please drink water.
Oh no.
What's wrong?
2:45.
Oh.
2:45. Do you know what that means? Jimmy the Python, here I come.
I'm sorry, John. Hey, you know, maybe if you just grease yourself down, you'll just...
Hey, stop!
We're working on radiometric dating, right?
I've noticed this is one of the most heated battles, this whole dating issue.
Well, that's because time is at the foundation for everything evolutionary theory teaches.
It's always cool when you can just smell the argument they're about to make.
Geologists now use radioactivity to establish the age of certain rocks and fossils. This kind of data could have shown that the Earth is young.
If that had happened, Darwin's ideas would have been refuted and abandoned. Instead, radioactive dating indicates the Earth is about 4.5 billion years old. Plenty of time for evolution and natural selection to take place.
Wow.
Wow.
Wow. Wow.
Wow. It seems that the foundation of evolutionary theory sure depends on radiometric dating. Radiometric dating is used to support the belief that millions of years exist for evolution to happen.
Before we go any further, I just want to take a second to point out that radiometric dating is super important, but it is not the only way that we can know the age of something that we find down in the ground. For example, there are relative dating methods, like biostratigraphic dating, for example, where we can see like this one artifact is in this particular layer of strata. I can't test the artifact itself maybe, but I can check all the other stuff in that layer of strata and figure out how old that is, and now I know this is in the same layer, so it must be the same age. So again, this is called relative dating, because we're dating this one thing relative to the stuff around it. We also have absolute dating methods. That's what radiometric dating is. It's an absolute method, because we're actually testing the thing itself and finding out the absolute measurement of the absolute age of this thing. And there are a lot of those too. Fission track dating, thermoluminescent dating, paleomagnetic dating is really good. So like, I know this video is just about radiometric dating, so I'm not going to fault them for not bringing up these other things. I just want to throw this out there, so in case for some reason you have some contention with how radiometric dating works, you should know it's not the only trick in the book.
And like they said, the entire age of the Earth rests upon radiometric dating. It sure seems that they're putting a lot of faith in something that they can't actually test through direct observation. After all, plenty of assumptions go into these calculations.
There are no assumptions, and we can directly observe this stuff. I mean, what do you think nuclear chemists do all day?
If it were to be disproved, their whole worldview would seem to collapse.
If you were somehow able to debunk radiometric dating and show that it was all some big scam, that would certainly throw a monkey wrench in our view of how the universe works, but it wouldn't do anything to disprove evolution or the age of the Earth. Like, the Earth is still very clearly way more than 6,000 years old. And evolution is still something that we can directly see right before our very eyes, both in the fossil record and in laboratory experiments. So like, we still know how mutation works, we still know how natural selection works, we still know how erosion and weathering works, we still know how strata are deposited one layer after the other, the whole law of superpositioning and all that, we still get that. So like, even if you were to get rid of radiometric dating, that's a problem, but we still understood evolution pretty well before we had it. So like, all it does is just add one more line of evidence. And that's the cool thing about really established science like this, is that it's not an island all on its own. It's supported by several different lines of evidence. Radiometric dating is one of them, but I would even argue it's not even the most important.
Pretty epic, eh?
Shut up, John.
Actually, the age of the Earth is based on the dating of certain meteorites.
They assume these meteorites formed at the same time as the Earth and that dating the meteorites will give us the age of the Earth. Cookie? I'm not gonna be...
Thanks. Wow, so they don't even use rock from Earth. I guess there's another assumption you don't hear about in class.
We can't use rocks from Earth to tell how old the Earth is because of plate tectonics. The crust of the Earth is constantly being recycled, being sucked down into the mantle, boiled, and then pooped back out onto the crust again through volcanic activity. So like, there are very, very few places on the crust, maybe like the very cores of continental plates, for example, where we can really kind of get a grasp of just how old this place is. Fortunately, meteors and stuff out in space would have formed about the same time that the Earth did, and those don't have any tectonic activity. So we can go test those rocks, and they'll tell us how old the whole solar system is, not just the Earth. Now, granted, these aren't Earth rocks, so there is a little bit of a margin of error in there, and that margin of error is around 50 million years, which sounds really big, but remember, that's 50 million years out of 4.6 billion years. So really, that's around a 1% difference. So we're pretty darn close.
Wow, this thing still has frozen.
Now, pretend the water bottle is a rock. Rocks contain radioactive material called the parent element, or isotope, which decays into a non-radioactive stable product known as the daughter element, or isotope.
Okay, I remember now. So, it's like the ice that slowly melts into the water.
Yeah.
That's actually not a bad analogy. I am totally stealing that next time I teach this.
So when they discover a rock, they can measure the amount of parent material and the amount of daughter product, and using a chart like this, determine how old it is.
So what's wrong with this method?
Well, the methods measure only the amounts of isotopes in the rock. This is good science because it is observable and repeatable. It just gives the ratio of one element to another. But the age is an interpretation of those measurements, not an observation. And that interpretation assumes answers to all kinds of untested questions. What if the rock already had a daughter isotope in it from the very beginning?
Where would that have possibly come from? These things have a set rate of decay. And even if there was some sort of weird contaminant in there, we usually take several samples from the same source material. So they're all going to line up. If one of them doesn't, that tells us that there's a problem and we would go back and correct for it. The type of contaminants that would throw off a measurement like this are not the type of thing that your average geologist would just have on their body to accidentally spill on this rock, so that's probably not an issue.
Or what if the rate of decay was rattled at some point in the past?
Well, that just makes no sense. Unless the laws of physics were rattled, the rate of decay is going to remain constant.
What was the original ratio of parent to daughter isotope?
We can know that because we know what the current ratio is and we know what the rate of decay is. This isn't magic, it's just algebra. If you have two parts of a three-part equation, you can figure out the third part.
One must assume no parent or daughter material was added or removed from the rock, and that the rate of decay has always been constant over millions and millions of years.
Again, unless the laws of physics were different at some point in history, or there was some dude just seamlessly injecting unstable isotopes into various rocks, this isn't a real concern.
But the most convincing evidence is all the crazy dates they get with radioisotope methods. I wonder if our teacher even knows all the assumptions behind radiometric dating. To be fair, there are lots of dates that agree with one another, but there are many...
That was such a weird interjection. I feel like that was a clip that was supposed to be way earlier on. I wonder if Jimmy the Python's on Instagram. And they just accidentally put it right there, and then just nobody was paying attention, so they just left it in there. I should point out here that there are a lot of elements that we can use as radiometric clocks. It's not just radiocarbon, which is the big one that everyone freaks out about all the time. There's carbon, there's potassium, there's argon, there's lead, there's uranium. And the cool thing about this is that their rates of decay, the ranges at which they cover, all overlap with each other. So like you would have two different isotopes that cover the same time period, and you would test for both of them, and you better get the same answer with both tests, otherwise you know something is wrong. So again, this isn't guesswork. There are no assumptions here. There are ways to check and double check our work, and any good scientist would do those checks.
But there are many examples of different mineral components of a rock giving very different radiometric dates, and very often different isotope systems give different ages for the same rock. So how can you know which one is the right age, if any?
So this part just simply isn't true. The only time that we're going to get wildly different dates from the same rock is when creationists try their hand at radiometric dating, do it wrong, get crazy results, and then try to publish those crazy results as proof that radiometric dating doesn't work in the first place. And that happens a lot.
And then there are rocks we know the age of, where we watched it cool from lava, that give radically older dates.
Really?
Yeah.
A lava flow in a volcano of the North Island of New Zealand that happened in 1954 was dated to be 3.5 million years old.
Okay, so that's an interesting citation. That could actually be a problem for us. Let's look that up. Excess argon is the Achilles heel, potassium argon. The study was published by the Institute of Creation Research. The only time that we're going to get wildly different dates from the same rock is when creationists try their hand at radiometric dating, do it wrong, get crazy results, and then try to publish those crazy results. Yup.
This rock was taken from the Ono Formation near Redding, California, where millions of sea fossils have been found. This lower Cretaceous rock is supposed to be about 112 million years old. But the marine fossil stuck inside the mud rock, an ammonite, showed 36,000 radiocarbon years.
How can a rock be 112 million years old if it holds a fossil of only 36,000 years using a different method?
Radiocarbon ages for fossil ammonites. It was published by Answers in Genesis.
Let me see your diamond ring.
You mean my purity ring?
John must be crushed.
Hey, At the jewelry store, the science said diamonds take billions of years to form deep beneath the earth.
I doubt that. Researchers find carbon-14 in diamonds.
Why is that important?
Radiocarbon decays quickly. It has a half-life of only about 5,730 years, so its maximum shelf life is only about 100,000 years before it becomes undetectable. And it might be impossible to contaminate an old diamond with young carbon.
Wow, so those diamonds must be younger than they think.
I just Googled, can you find carbon-14 in diamond? And the results are all Answers in Genesis, Institute of Creation Research, ScienceAgainstEvolution.org, Creation.com. Guys, you gotta stop this. Learn how peer review works.
So here's the real question. Why are any of these examples in our textbook?
Because it's a science textbook, and what you're talking about isn't real science.
It goes back to the original quote we read in the book. If they're wrong about dating rocks, then the entire evolutionary theory crumbles to pieces.
That's true. None of us were there to verify the assumptions.
But God has provided a written account of history. And if you tally up all the chronologies and time cues in the Bible, the Earth is about 6,000 years old.
The chronologies that you find in the Bible are largely based upon the life stories and genealogies of people who supposedly lived to be hundreds and hundreds of years old. Noah, for example, was 600 years old when the flood happened, wiping out all life on Earth aside from him, his immediate family, and all the animals that he could fit on this little boat. So putting that into perspective, he then would have had enough children and enough children with his own children to populate all of Egypt and all of Egypt's Hebrew slaves, because the next book is Exodus, plus all the people in North and South America and Australia and Indonesia and South Africa and East Asia and Europe that the Bible just fails to mention. All of that within about 300 years, because he died at the ripe old age of 950. So he was a busy dude. Is that really where we're taking our cues from? Hey there, editing Forrest again with a really quick interjection, because this part kind of bugged me when I went back and rewatched it, because although parent and child incest is pretty common in the Bible, especially in the Old Testament, I realized that this isn't the only possible explanation here. So I looked it up, and I found that Noah had 3 sons with him on the ark. So that's 4 total families that had to repopulate the whole world. There were 8 generations between Noah and Moses, and the time span there was about 850 years. I also looked up, the U.S. Census Bureau has a historical estimate for the world population at the time of the building of the pyramids, and they have that at about 10 million people. So we've got 4 families over 8 generations, producing 10 million people in 850 years. So the exponential growth formula there would be 4 times x to the power of 8 equals 10 million. You divide out the 4 and you get x to the power of 8 is 2,500,000, and the 8th root of 2,500,000 is 6.3. So what we could be talking about here is every single human being on the planet having on average 6 children, and their children having 6 children, and their children having 6 children. No kids ever get to die. If you forget to do your job, then, the next person in line, your neighbor, has to have 12 kids over and over consistently for 850 years. That would produce all the people in the world, who would then spread out from there and populate all these other continents and make all these other civilizations that the Bible decided wasn't important. So just watch for the creationists who come into the comment section and say, aha, see, it is mathematically possible. Yeah, it's mathematically possible. It still makes no freaking sense.
It's like it says in Job 38:4. Where were you when I laid the foundations of the earth? Tell me if you have understanding. It's like God saying, you weren't there.
The book of Job also talks about unicorns. Just throwing that out there.
Kind of makes you think, doesn't it?
Nope, it sure doesn't. I've read the source material and it is not thought-provoking. Well, this was a fun one. Overall, I give this one a science teacher challenge level 4 out of 10, which I'm pretty sure is the same thing that they got last time, because you actually have to know how to read more than just the title of a scientific paper, which is something that not a lot of people know how to do. There are a lot of other videos on this playlist. Natural selection, vestigial structures, common ancestors, fossils, whale evolution, like, we could do a lot of these. I don't want to pick on John and Jane too much, but if they're gonna keep putting out hilarious videos like this, it's only fair that we keep talking about them and maybe learning some real science along the way. So let me know in the comments below if you want to see more from this series. Thank you so much for watching, for liking, for commenting, for subscribing, and all the other stuff that you do here on YouTube. Please exit through the gift shop on your way out. Pick up one of these sweet t-shirts. If you like terrible podcasts, I've got one of those linked down below. I hope you have an awesome rest of your day. Watch out for Jimmy the Python and never stop learning. Bye-bye.